Ron Brash is a manager in risk advisory at Deloitte and was the lead in developing and running the ICS Detection Challenge. Please welcome Ron and Dale to the S4 main stage to announce the challenge results.
Yeah, I'm not going to sit. I get too passionate when I talk about detection here. So, and the reason for that is I actually, back in 2004, we had a DHS contract, and way back then we wrote the first snort signatures to detect Modbus and DNP3 issues, and eventually some preprocessors. And then for about 10 years, nothing really happened. And ours were very primitive. I'm not claiming they were works of art, but we were expecting a lot of people to pick up on that and move forward, but it didn't happen. Until about 10 years later, a few years ago, we started to see companies be created and formed just to service the ICS detection market with new products. And first it was a couple, and then more and more, and eventually it was over 20 companies trying to, through passive means, do asset inventory and ICS detection of attacks. So this was very interesting to me, and I started to talk to these people, and I've written quite a bit about it in podcast and videoed, and I actually just tweeted out a link right before this of all my analysis of the market. If you can see that at Digital Bond on Twitter. But what kept happening was I'd get these demos, I'd talk to the people, and it looked good, and I'd say, well, why is yours better than all these others? And I'd get an answer, and that answer was the same as all the others. And I'd say, well, that's exactly what I heard from all your competitors. So why is yours better? And the next response I get was just a more emphatic, ours is better. So last year we created this ICS detection challenge in an effort to try to put some technical measures against this, to actually say, okay, well, let's actually test it. And so Ron and a few others, Eric Byers, myself, we worked with an asset owner, and we put together a challenge to test their ability to create an asset inventory and to detect events we had inserted in real-world PCAPs to test them. And we had Clarity, Nozomi, Security Matters, who is now Forescout, as well as Gravwell there. And it was good. I mean, I think there was some real value to it. We learned a ton, though, and so we were really excited to come back and do it again here with a much better process, much better data. So in this case, I personally this year went out and collected the PCAPs, tremendous PCAPs. We had about 400 gigs worth of data. We had, a smelter system that was run with a Rockwell system. We had some mills that had a lot of Modicon stuff and iFix and Pi. There was actually a DCS involved. So a lot of mainstream things that I thought they'd do good on asset inventory. But we also had packet captures from the mobile fleet, things like haulers and shovels and slope integrity systems. So we had some things that were really going to challenge them. And then Ron, he's going to tell you what he did, but the things they did to put together the challenge for detection were really amazing, and I think you'll be blown away. It's by far the most I've seen outside of a classified arena. So had a really good challenge set up, and we got early on, Clarity and Drago said, hey, we'll do it. Our expectation, since we're starting to see a tier of, a top tier of 4 vendors and then kind of the others struggling to catch up, we thought a lot of those other 20 vendors would want to compete against them so that they could prove their technical solution was equal to it. So we contacted all of them, answered all their questions, and none of them said yes. And you can draw your own conclusion as to why they chose not to compete. There certainly is some risk in competing. If you don't do well, if you're not as good as the others, it's going to hurt you in the marketplace. But for a lot of these vendors, they're already hurting the marketplace. So we thought this would be a good opportunity. But they said no. So in December, we were at a point where we had Clarity, Dragos, and Kaspersky, and an open source team involved. And we were still going to run the challenge. But then Clarity made a decision at the end of the year that the risk was not worth the reward, and they said they were no longer going to participate. So we're kind of stuck. And with all this hard work, I didn't want to throw all this hard work away, especially, Ron and his team. I mean, it's one thing to collect PCAPs and asset inventories. It's another thing to invent attacks and insert them. So what we decided to do, and this is what you're going to see here today, is we have the two commercial vendors, Dragos and Kaspersky, who actually, were committed and willing to do the challenge up to the end. We gave them a portion of what we were going to do in the challenge, and we gave that to them on Friday, the packet captures, and we gave them what would have been the score sheet. And we said, okay, you have up until Wednesday to use your tool and tell us what you found. So no asset inventory in this case, just the detection phase of the challenge, or what would have been the challenge. And so we're going to have Ron describe actually the attack that he created, and then we'll bring Kaspersky out, and they'll walk you through. They actually have videos of how they analyze this and what they found, and we'll talk to them a bit. We'll do the same with Dragos. I will say, there's always a concern about commercialization at these events. This will, because they're showing you their product and their approach, this will be a little more commercial than what we originally intended. But I think it's useful to actually see this process and work, and we'll ask them some tough questions, don't worry, so we'll kind of even that out. So with that, I'd like Ron maybe to go over the attack.
Yeah, so I want to just do a little bit of a into this. So since last year's challenge, we upgraded the tools and the methodology for anonymization. It was one thing to look at 3.5 gigs last year. Dale gave me this little gift, a portable hard drive, midsummer I would say, and it was 400 gigs. And then later on I got an inventory sheet. But I walked into this, as kind of just as any competitor, and I had tons more time. But I had to upgrade all my tools. I had to figure out a new methodology. Computational resources were all a challenge. We had to greatly expand our data set. I had to expand my knowledge. I've never seen some of the mining traffic, and the attack samples too. And what I realized out of all of this is that, as a vulnerability manager for several companies, there's always noise, there's always challenges, and if I'm a good attacker, there's multiple segments, and I want those rabbit holes. And the other thing out of it is I work on and deliver a lot of different tabletops, and this is not just a asset vendor test. This is a way to creatively push every team on their IR process, push them on live fire exercises, and this truly was an advanced threat scenario, which I'll outline now. So why do we do the challenge? So I don't like to sleep. I don't know if many of you do, and I know the teams that participated didn't like to sleep either. This is a version 2 community event, and it was an attempt to discuss and share sensitive information in a way that makes sense. It was a way to share across industry-specific technological idiosyncrasies, assist vendors with testing their product, but truly validating some of the claims. If I'm X company and I have all of these vendors, how do I pick the one that's right for me? When I go choose a car and I go purchase one, I choose what is my budget, my lifestyle, what is, kind of what fits my mold. And that's the thing is there's not necessarily one is better than the other, it's what's best for my installation or my business culture. And the reality of all this is that this was to provide a moving benchmark. Last year was one approach for live fire based on a particular set of data. This again was another. It was difficult, and I wanted to do it in a fun way to really push and take away, a lot of teams and products confidence values, and they really had to push themselves and test their products. So you couldn't be just packet jockeying. And the other thing is that this was way more complex than version 1, way more. So I really want to thank everybody that put this together. So Schneider Electric contributed, Rockwell, Allen Bradley, FireEye contributed, Gravel contributed. I believe Corey is not here, unfortunately. And from an independent perspective, Deloitte allowed me to be here and to do this. So I funded this out of one of my own projects. So absolutely neutral. These are all my independent opinions. But thanks to everyone involved, and thank you all for participating openly and allowing us to do these things. So the scenario. So it is a mine, and so I wanted to kind of play with the whole story that I did last year. And it's Quebec core, so it's a resource mining specializing in copper. It's situated in northern Quebec, so up north in the French part of Canada. And their operations consisted of mining, processing, and refining and smelting. And based on that, the challenge is actually harder than reality. So this is an unknown environment. Yes, I got an inventory list. I have an IP. I have a device, I know a version, I know what cards in it. That's all I know. I don't even have a map. So part of that, I had some limited time, but I also even pushed the vendors, if the challenge had gone the way it did last year, to have 8 hours to handle this challenge. This would have been truly a hard challenge for many, many teams to handle at an incident response level. There's a massive amount of traffic. There's sample noise, because that's real life. And this truly is a nation-state style attack. There's not just one attack in there. There's not just a few malware detections. It is far, far greater than that. So as Dale said, there's over 200 million packets in this sample. And this is a small subset of this. So there's 130 gigabytes. There's five major different zones. And there's actually about 7 zones altogether. So here's the attack scenario. As you can kind of see, this doesn't show how many nodes and how many assets you have. But there's an external kind of IT/OT convergent factor, and there's a discussion, based on whatever vendor you have. If I don't really like the term maybe OT from a perspective, right? But what everything came in is it came in through the DMZ. And what I wanted to do is I played with gray energy to start some of the noisy attacks, and I didn't give a hint. I delivered this with a bang. If you may have saw, there was an open letter that I sent out with a slight hint, and no one actually got it. But there was so much more there. I wanted to push every single person. So the attack came in through the DMZ to a vulnerable box. And from there, what we did was we did a lateral movement across with gray zone and with some beaconing on the DNS server. But attached to that DMZ was also the business network. And so I did a few things in there as well. So I just to mislay, because a lot of people are going to look at your business network first for falsities. So inside of the business network, for example, there was Stuxnet, there was Havix, and I did that on purpose to make sure everyone went down the wrong. So from the DMZ, then I managed to get a box that would then jump into across a couple routers with some unique configurations into where all of the jump zones are in the RDP servers and your sessions, your terminal servers. Now, when we think about terminal servers, they're usually often resource limited and so on. So what I really said, these are really powerful privileged boxes that have many ways into the network. But one of these servers then, because of his privileged access, gets to talk to a VMware machine. Now this server, it's a server 2008 R2. It actually is hosting the Pi server. It is also having the SQL data, and it's dumping all of the tabular data across from the RDP sessions and into the DMZ as well. So this was really what I would go for if I was an attacker. This is a privileged box. This is where your tel vents are. This is where your Pi servers are. So from that box, there was kind of a slave situation where inside of the QSX zone, that box inside of the PCN was actually feeding information back and forth. But it also duplicated a really, really privileged HMI and dev box. So that box was talking to a whole bunch of different PLCs. So as the attacker wound through there with a bunch of WMI exploits with lateral movements, with backdoors, there's even a HTTP reverse backdoor, we go downwards. And I did a few things just to test people. So I had some Schneider Electric devices. So if we look at the bottom one out of the QSX, which is on the I guess my bottom left-hand corner, I pushed an Allen Bradley firmware to a Schneider Electric Mac just to see if people would catch these kind of challenges. Some things snuck through, some didn't. There was a PLC DOS. Well, most PLCs, if I do something called a slow low-res attack, all of the web servers will die. Very few things can handle that. But what I did, something really, really unique, is you're looking for non-standard things. And from that attack, what I did was I fed in through a Schneider Electric PLC, and I did a quantum programming code with some extra bits attached to it. Now, that was something to simulate something like with the tri-connects, with some logic that you're not necessarily going to see going across your network unless you're truly looking for it. And this is where, and this is the end game, and it was actually, there was a hint inside the challenge, you have the power. Well, that final step is a telemechanic device inside of what's called the powerhouse. And that one is controlling everything. And so there was a bunch of unique attacks, and I ended up killing that device, and that is the end game of the challenge. Given that there's 8 hours and to accurately follow this whole path, it is really complex, and it's truly something that is on another level. And so we'll talk a little more about who and what and how far everyone got. So for the open source team, so who are they? There's 2 individuals here. One's an asset owner that wanted to see this from his challenge. He was a former IT guy, really loved Linux. He provided tier 3 support for specialized instances, but this is not his mainstream job. And we wanted to see if you could go in there and jump in there with all the tools, if you have the passions and the hobbies. The other team member was a former asset owner turned vendor, and he had extensive background in OT operations, and he may provide support for specialized interests. So their approach was to look at the various open source tools, do customized scripts, look at the data, and just to try to understand which tools they should use. There's so many out there, and this is kind of the same as a vendor, or as a client. Which vendor do I choose? What tool is best for me? Well, these gentlemen, they really struggled to figure out which tools work well for them. Then they had to make all the data greppable. So they walked into this without the research that I managed to do last year, and they had a real hard time. And then they tried to visualize the data without an inventory list, just like I had to do so initially. And then they had to walk through the data looking for breadcrumbs. Now, from that, the things get harder and harder, and truly, so they use Bro, NTOP, everything that was available. But as someone who uses a lot of these tools, and throw me into the whole debate about why I should have OT tools or IT tools, a lot of these tools have unique flaws, and you shouldn't necessarily trust them. And that's where I let in even more surprises, because I know the limitations of those devices and those tools. So this group, they managed to get in. They saw what happened in the DMZ to a certain extent. They found the signatures for some of the stuff that was going in between the DMZ and the business network. So if you see the grayed out items, they didn't see these elements, and they didn't outline them as part of their their solutions or their results. So they only found a mix and a match of a few things. And the results actually had some false positives, but also the false positive, for example, given the redundancy, what appears to be, let's say, ARP spoofing is actually the redundancy of the DCSs. So there was a few things there, and unless you're familiar with those unique features of these devices and the network layouts, it's really a challenge, but they did great. So for Kaspersky Lab, we're gonna cue a video.
So with that, before we jump to Kaspersky,
yeah,
I think I had a chance to talk to the gentleman, one of the two people who worked on the open source team, and he was kind of surprised how hard it was, I think.
Oh,
in this,
absolutely.
I would tell you, this is a very talented person, and I think they probably, if they had spent months getting up to speed and learning their tools and such, they would have done better. But just the idea of, hey, I'm going to take open source tools and I'm going to replicate what is available in some of these commercial tools is not a short effort. Is what I think he came across.
Absolutely. So I kind of have also another advantage. I was working for Eric, for many, many years, and I had access to all of these tools, and I got to experiment on my own time. So I had a leg up on that whole process. Not to knock those individuals, but I knew which ones to play and match as well, and where the limitations were. So they walked into this blind and had a challenge.
Yeah, and I think it would have even been more difficult if we had the 8-hour time limit if they had come in, with tools loaded on a computer. So. I don't think it was really a statement on how good or bad the open source tools are. It was more of a statement in their case of how much work they would need to do in advance to get value out of the open source tools. But they did find some things, and we're glad they participated. So now let's bring out the Kaspersky team. We have Vladimir Dashenko, come on out, guys, and Alexei Shulman. So thank you for them for participating. Guys, sit down. And so what we did is we asked each of the teams to put together a video that kind of showed what they found and how they found it in their system. And I think, Alexei, you're gonna narrate this video. So if we could play the Kaspersky video.
Hello, everybody. During our analysis, we detected 5 major incidents in this traffic. 3 of them are related to well-known APTs and malwares, 1 of them to XSS vulnerability, and the last one to deny of service vulnerability. First incident we called Stuxnet incident. We detected the attempt of exploitation vulnerability with code name MS10061. Here you can see that our asset detection engine successfully recognized machine on which this attempt initially was detected. And on the event page of our product, security officer can find additional details about this incident. I mean, first of all, signature or detection rules of our IDS systems and information about all machines which were involved in this incident. Information, I mean IP addresses, MAC addresses, network protocol which was used during this attack, and port numbers. All information is here, and on the next screen we will see 2 files, 2 samples, which were extracted from this industrial traffic. So just wait a couple of seconds, please. 2 files which were extracted from this industrial traffic. On the left side of this screen, you can see the Stuxnet malware itself, and on the right side of this screen, you can see MOF file, which will execute the malicious one, the first malicious sample, when this vulnerability will be successfully exploited. Next incident we called HAVEX incident. It is related to HAVEX malware. Probably you've heard something about HAVEX malware. It's a simple malicious downloader. All what it does is just downloads additional modules in the form of dynamic link libraries and runs them. We detected suspicious activity. We detected that one infected machine, probably compromised machine in corporate network, sent requests to command and control server of HAVEX Trojan. Here we can see that our set detection engine was able to recognize this machine with Windows 7 operating system installed. And as in previous case, on the event page, security officer can find additional details about this attack. IP addresses, source and destination, MAC addresses, source and destination, ports numbers, and so on. We have here one incident with two events, two detections. Well, actually, HAVEX is a simple, ordinary malicious downloader. It sends get or post requests to its own command and control server, and command and control server returns HTML document with long base64 encoded string, like it will be shown on the next screen. HAVEX tries to find this long base64 encoded string between two HAVEX words, and if so, then it means that this HTML document contains a malicious module of HAVEX malware. And after processing this long base64 string, after decompressing it, HAVEX gets its module extracted. The third incident is related to well-known gray energy APT. We detected several requests from internal network to IP addresses and domains which belongs to gray energy infrastructure. Here you can see this incident in our product's dashboard. Our set detection engine again was able to recognize machines which were involved in this incident. Actually, only one machine. Yeah, only one machine with Windows 7 operating system installed, yes. And on events page, there are additional details about this incident for a security officer. I mean, again, IP addresses of source and destination, MAC addresses and port numbers, and so on. Third incident is about cross-site scripting vulnerability. And here we can see a short description of this gray energy incident and information about machine which is involved in this incident as well. Also, we would like to show you these two requests on the next screen. The first was successful. The first connection was successful, and the correct response was returned to the probably compromised machine. Yeah, here you can see it. And on the right side of this screen, you can see another request. It wasn't successful. Probably the second server is dead now. Yeah, here you can see it. And getting back to incident number 4, incident which was called Rockwell cross-site scripting incident. We detected suspicious activity in this corporate traffic. Just a second. Yeah, incident number 4. Here you can see that this incident was displayed in product dashboard. By the way, we have a special correlation engine in our product Kicks for Network. This engine can combine different events in one set and decide if this set of events is malicious or not. So here our set detection engine recognized that this PLC is by Rockwell, and all details as usual on the event page. So let's sort them. Just a second. Let's sort them. And our incident will be on top of this list. Yeah, here you can see at the third place. Let's expand it. And we can see here that this incident contains several events. For example, PLC unit received get project name command and returned very weird response. We decided that this response is weird because it was unusual, untypical. This answer, like it's shown here, contained very weird string. Actually, this is probably malicious JavaScript inliner. Yes, and also here are some details about this attack and a short description. Yes, we don't know how exactly this PLC was compromised, but probably we assume that attacker used vulnerability like it was shown on this screen. And the last incident in our video, incident number 5, PLC denied service incident. This is the complex incident. It contains of 5 events. Let's make it a little bit bigger. Now we can see that attacker just updated firmware in PLC unit. After that, he or she sent reset command, and finally, this PLC has stopped working. We sure that this activity, I mean, firmware update, is a dangerous activity, and we definitely should create incident in our dashboard about it. That's all for now. We have shown 5 different incidents in our video, but of course we found 3 minor incidents, but we decided not to include them in our demonstration because they are actually pretty simple. They are about weak credentials, network scanning, and so on and so forth. Thank you. Thank you for your attention.
Moving ahead, so this is actually how Kaspersky across the board. So they did a great job. They found some stuff that one team or one vendor didn't find over the other, and they have their own approach, which is a representation of their methodology and their culture as an organization. So inside of the DMZ, they managed to get everything fairly accurately, and they also started bridging in between the business network. Unfortunately, they weren't able to link between the LS or the QSX, but that's where some of the PLC attacks started to happen. And some of those things that they mentioned as an attack are actually OT flags. So there's 17 actual attack steps in this actual data set, and there's about 13 actual OT-based flags that I added as well. So I did this on purpose to add noise to see whether or not people, that's why you need an operator to know when things are gone. You need to know when you have a maintenance cycle. You need to know when people are pushing things to your devices. So in the bottom right-hand corner, that's where Kaspersky started to see the PLC error. So this is how they did and how are they able to link a few things. So I just wanted to focus on the bottom corner and also on the left-hand side. So for Dragos, I'd like to welcome them.
Let's talk to
Go ahead.
Kaspersky.
Yeah, please.
So, Ron, what you're most deep into this, and you created the challenge. What area did you think they did best in? And then, of course, I'm going to ask you the area where maybe they didn't find as much as you expected.
So I think everyone really did great, and particularly Kaspersky. They had a lot of strengths and understandings. Some of the firmware changes, some of the things that were really noisy events, and maybe that's what your organization wants to focus on, like from an IR perspective. You guys, you understood there was a lot of assets there. I could see that you had everything listed out. I think you guys did really great there in identifying what the devices were, and also looking at some of the attacks. Maybe an area of improvement would have been double checking that one of those firmware uploads was to a Schneider Electric OU. So there was little gotchas and all of there, and I think you guys did great. But some of those things are just little tricks for me to double check your sanity on some of the results. So I think your UI looks great, and I think that you guys did a good job challenging this and walking in this blind for your first time around. So great job.
Thank you. Let me ask you a question, and Ron, please chime in with questions. But so when you got these PCAPs, a bunch of data, and a few days to work on it, how much of what we saw in your results was just something that your product generated automatically, and how much of it did you have to do, the analyst activity? I know that's a kind of a broad question, but can you give me some sort of feeling as to how much of each there was?
Most of the events, they were detected automatically by our solution, and we had to double check a couple security alerts. So for example, the cross-site scripting vulnerability. So the product detected as the suspicious activity, and we double checked it using like human analysis, and then we saw that yes, there is a cross-site scripting, and we decided to analyze. So is it like a CVE? And we inputted in our results that there is a possible CVE, the number of the CVE. But in general, the product detected most of the events. So it sent the alerts, some suspicious activities. So.
Well, and one thing. So we also had. The plan for the challenge was, if you look at the score sheet, and they all filled out a score sheet, but we didn't, again, since it's hard to have a competition with two, we didn't actually create scores and aren't going to publish scores. But there was columns that said, related to previous incident, related to next incident. And you really didn't tie any of these, you showed a lot of, I don't know where there were 6 or 8 of them in the video, but you didn't really show an attack flow in your score sheet. How would an analyst deal with that? Would that be something that your product would do, or is that something the analyst would have to do?
So the attack workflow is usually done by the analysts, but talking about this particular data set, it's like it's super concentrated with different noisy traffic, network traffic, a lot of different attacks and everything. So in the real attacks, so it will be easier to build the attack graph, and I guess.
Where's my microphone? It's very important to mention that our product can do this activity too, so it can construct attack chain.
Okay. Do you have any questions?
No, I'm waiting for the open floor so you guys can battle that with Dragos a little bit. Okay. That's what I'm waiting for. Again, it's what you guys are doing. It's a reflection of your methodology, the Kaspersky process, the business culture, and that shows. And I think you guys you're doing great, and I hope to see you around next year for this.
Yes, we hope to participate again.
Okay, so we'll have you both go off stage. We'll bring Dragos out, and then Vladimir, you can come back. So thank you very much, guys. So let's send out the Dragos team. We have Dan Gunter and Danny Buentello. And thanks again, guys, for doing this.
Guys.
And I think their video is complete with narration, so if we can make sure that shows up and we can roll the Dragos video.
Today we are going to show the Dragos approach to not only the S4 challenge, but also ICS security monitoring, threat detection, and incident response. We understand that system owners manage large amounts of assets, and identifying threat behavior can be difficult. One way we make asset management easier is through zoning and timelines. Having context of which zones as well as which assets and users are communicating over a certain time is key. At Dragos, we believe anomaly detection won't always allow you to recognize key threats, like an insider or targeted threat actor. The Dragos platform equips a SOC analyst with context and tools to comprehensively identify assets, effectively detect threats, and efficiently respond to incidents. Our first step when launching an investigation is to look at the 4 types of detection dashboard, where we notice a configuration detection of saved HMI display. We pivot on the asset ID information in the alert to the Map Explorer view and filter by server message block traffic. We notice that the user connects to multiple Rockwell devices and workstations from a Dell system. The Dragos platform provides the analyst with a query-focused dataset, QFD, for Rockwell audit logs. QFDs enable faster investigations and reduce time spent looking at irrelevant data. When digging into the audit log QFD, we see an operator refreshing the human-machine interface pages on a Rockwell FactoryTalk View Studio system. The Rockwell HMI product has vulnerabilities associated with the system. This detail helps identify when an attack occurs and provides the SOC analyst with the who, what, and when to investigate this user behavior. While this activity may be normal user interaction with the system, the Dragos platform provides detailed asset identification and management to aid your analysts in building experience strengthening relationships with system owners, and potentially preventing impact caused by a rogue user. Configuration detection, coupled with asset identification, is only one component of fully understanding and protecting your industrial environment. Another component is threat detection and response, and the associated tools provided by the Dragos platform. The Dragos platform detections dashboard provides contextual information in a simple view for analysts to identify potential incidents. The threat behavior pane on the dashboard helped the Dragos team identify tactics, techniques, and procedures associated with the malicious industrial campaign Havix. Tracked since 2013, Havix steals intellectual property to support attack development on industrial control systems. Dragos was made aware of Havix from an intelligence-driven analytic associated with known threat behavior, in this case, a successful attempt of specific communications. The Dragos platform identified another procedure associated with this threat behavior, increasing analysis confidence. This information is presented in the Dragos detection dashboard to enable analysts to start the initial gather additional information. After multiple Havix notifications, analysts are guided to the Havix-like activity playbook for triage. Playbooks provide triage steps, including scoping of the potential incident, as well as its associated notifications. After identifying the investigation scope, the next steps include identification of scanning activity and exfiltration of data indicative of additional Havix tactics, techniques, and procedures. To continue the S4 incident investigation, we pivot back to the Dragos platform detections dashboard. We immediately see notifications for gray energy, an advanced state-sponsored malware used by adversaries to target industrial control systems. We create a case from the notification noting a host making external connections related to gray energy behaviors. As we work through the investigation, we can also see other notifications and notes taken by all analysts working the case. Using the map feature, we can see connections from the infected host to external assets related to gray energy. Using the Dragos platform, we identified a DNS query, an HTTP GET request, a file transfer to the internal host, and an HTTP connect to tunnel to another external asset, all typical of gray energy behavior. The map feature allows us to quickly verify whether the suspect host connected to internal assets or to confirm that this was the only internal host that connected to the malicious external assets. In case management, we see a notification that the same suspect host opened Mimikatz-related files on another internal host. Use of Mimikatz is a common adversary behavior to harvest credentials to pivot across networks. From the host system where Mimikatz was located, the adversary pivoted through multiple other hosts using NTLM and RDP access with administrative user accounts. By pivoting between several hosts in the Dragos platform, we detected a host with many failed authentication attempts followed by a single success, indicating a brute force attack of NTLM accounts to gain access to OT networks. We attached a diagram from the map feature showing elements of the overall incident to the Case Evidence tab. We can see the gray energy related connections to external hosts and pivots through multiple zones, including OT networks. This concludes the summary of the Dragos team's findings of some of the major events from the S4 detection challenge. For any questions or to learn more, contact info@dragos.com.
Great. Okay, Ron, why don't you show how they did on the scoreboard here?
Yeah, definitely. So as you probably got from the video, Dragos, I really tried to challenge all vendors on valuing their confidence factor and how they looked at events as part of their investigation. And so as you saw from the video, Dragos really nailed and understood what was going on the left-hand side. You know, as you can start to see, and again, let's put things into perspective. You had 8 hours to look at 130 gigs of, me being as devious as I can possibly be. So I tried to demolish everyone in a fair way just to play with everyone's tool and to challenge them. So I was the chaos monkey here. And Dragos really got to figure out, they knew the stuff that was happening inside of the business network. They knew, and they started to cross over inside of where the terminal servers were. Without a doubt, they understood how the attacker got in there, and it looks like they were able, and truly they were able to, with their tool, to link the events there with a high degree of confidence. So you guys did great in that regard. And that, for me, that was really, really impressive. I really wanted to challenge everyone last year on that same premise, and it takes a lot to hide those things. I added a detection in, I put a pause, just like everyone else would do if I was a real adversary. So Dragos was able to link those zones and able to handle and understand what all those PCAPs were doing. So I think they did great there, and the tool really shows that from an automation perspective.
Great. So guys, you obviously had to work hard, but you had 4 days to do it as opposed to 8 hours. How would have this analysis changed if it was live? So just to give you an idea, and I want to talk more when Kaspersky is back. The collection we did was at most 3 hours from all these networks. So this amount of traffic of which you got a subset was at most 3 hours of real world data at one facility in an organization that has many facilities. So if you were faced with this and it was happening real time, how would you have addressed this?
Yeah, so really our approach for this, how we kind of played it, and so full disclosure of how we approached it, really the only difference would have been how far down the map we would have gotten. Because on our side, so we had primarily 5 analysts at the office, SOC-trained analysts working it, and then we had our engineering team helping with the support side and with just platform issues with that. So really what you're seeing with the diagram being built out is really the first 72 hours of what a trained SOC analyst can do, or what we can assist a trained SOC analyst do with that. If you only did 8 hours, we would have probably still started with the same, right? Because when you're going to a brown site, right, and you're starting to do a threat hunt on a brown site and you're showing up, it's going to be like, okay, let's see where the most bleeding's occurring that we see, and we're going to triage from that. So,
okay. Ron, do you have a question for the team?
Yeah, so I did a few things just to challenge your confidence, and I know I did it for Kaspersky as well, so I'm going to ask that same question when they come back out. It just cued my memory. How did you guys handle, kind of digging into it? I know you had to build a profile of me and what I was doing from a devious thing. How did the Dragos team, which many of them have never met me, kind of get into the mindset when you started seeing the attacks? How did your team's methodology, feed back in there and start to understand what I wanted to do?
So a lot of it, honestly, and it goes back to the kind of our approach on like timeline analysis, right? So one of the key parts of incident response is timeline analysis, and using like Havocs as a red herring, it doesn't work because like that's a major incident if it's in your network, if you see Havocs or gray energy. And so where we really started on that was what you would expect whether you go through SANS or whatever your training is, to start with that timeline analysis and go. I would say with that, the biggest challenge is just noise, because it was a noisy network. To give an idea too, on the data set, some of the rock drills and mining equipment was in the DMZ. And so there was a lot of like really confusing stuff to an analyst too, that it's like, why are these OT assets actually in a DMZ when you actually put it on the map? So, yeah.
Yeah, no, definitely. And like, as we probably know as customers, and I don't like seeing alerts, especially when Microsoft gives them to me. Really, those flags, those things, those OT things, for example, there is pipeline data in there with writes in it, and some of that's actually real. If some solutions might see that and say that's wrong and send up an alert, and we maybe not have the bodies or the commitment of the organization level to handle those things. So I'm glad that you guys fed through and you were facing the challenges that everybody else would.
Yeah, and I know something we talked about too in the data, like one of the things, there were hundreds of Modbus writes from the outside of the network in too, so the challenge is for us as competitors, and especially with time, going back to your question, Dale, it's hard when you're both new to the map. We had a huge advantage of having an asset map that we quickly had, but when you're coming into it and like you don't know what's good or bad, right? So we do have to try to find the.
And I'm going to ask this other question. What did Kaspersky or what did Dragos learn, within the product?
Why don't we bring Kaspersky back out here? So,
Will do.
Danny, thanks for all your work. Maybe can we bring Vladimir out here? Thanks a lot.
Thank you, Dale.
Thank you.
Yeah, and a hand for the Dragos team for stepping up to this. Okay. So I'd really like to dig into what works and doesn't work, and kind of in line with what we were talking about, and like to hear your standpoint on this. One thing that is maybe artificial about the challenge is that you don't have a history with the system.
Yes.
So I guess there are cases where and we've seen this many times where people are not doing detection, don't have incident response, and people like FireEye and others get called in at the last minute. But if you were proactive and you were building this program using one of your tools, how much different do you think your results would have been? And maybe we'll start with you.
So usually when we do the setup of our solution to the customer at the customer facility, we know how does the whole thing works. So we work really close with the customer. We basically train our solution on the normal behavior. And so we can monitor like special parameters. So if you spend some time with the customer, training like the customer and the solution and put them all together, so it shows like, of course, better results. So as you mentioned, this data set, of course, was too noisy, and we did not know the history of the data set. What is behind of the data set? What is the technological process behind? So it can be different, right? So.
Do you have any thoughts on that?
And it's the same deal because I think there were 4,600 assets in there, and so there was an enormous amount of assets. But I would say coming in with a bad idea of what your network really looks like is pretty common. A lot of the threat hunts we do, we're bringing back a terabyte or two of data in 24 hours, and so you're having the big data problems, and these are in OT networks. And then our advantage there, the difference and the challenge is we can say, hey, of this one box out of the 4,600, what's the context to kind of what he said? So, yeah.
Well, what about, and this is probably the part that I was most involved with is, as I said, this was just 3 hours, just one site. I've heard the word noisy used a lot, but that's real world. I mean, we didn't inject reads and writes and things like that, except for a few that you did in the attack. What is it going to take if a large asset owner with 20 of these sites says we want one of these products to be monitoring all the time and tell us when bad things are happening and have analysts watching it all? How are we going to scale up to that?
Yeah, and to that point, that's where and kind of how our approach might be different is we're very much on enabling, like your SOC analysts are going to know the network better. And our advantage to that is like where some of the anomalies it might be tricky with anomalies, like that context is really hard to capture, but that's where like asset owners kind of also they have a part in whatever they choose to use on.
But are we going to start to see this tiering, or maybe you already have it, where at each site you're looking at the data, you're deciding, okay, this is what we're going to send to the SOC? Are you guys doing that or looking at doing that now, or does everything go back?
We have just a bit different approach to that. So we have the special thing to monitor all the solutions. Let's say the facility is huge, or the customer has like different factories around the world, and the customer wants to monitor all of them and what's happening. And as Alexei mentioned, we have the special correlation engine that can okay, so this engine works and it analyzes everything that is happening like everywhere on different facilities, can combine it and show to the security officer. So our approach is to monitor like everything in one place and provide the data to the security officer, and not only from the KICS, but also the Kaspersky Security Center can monitor from the endpoints, the KICS for nodes, the special anti-malware solution for industrial control systems. Okay. So,
what about from the Drago side?
Yeah, and that's where I'm trying to think on this one. Sorry, can you rephrase the question?
Well, I'm just wondering if we're talking about huge amounts of data coming from multiple sites. Here you had 3 hours from one site, and you had 25% of it. Is it all going to be sent to one place to be processed, or do you envision distributed processing being required, or maybe you're already doing it today? I don't know.
Yeah, and that's, it's tricky, right? Because first of all, you need the right data, and then you have to correlate the data, and it's a really hard challenge, and it's where we, as even the S4 community, can help. Because even helping identify like the Rockwell data for those attacks, right? are there white papers, like, right? Having white
Yeah, good
papers
luck.
for all those attacks, right? We have to know as a community before we can get it in. And once we know as a community, then you can say, hey, you know, these are the data sources we need. The challenge with correlating that is at some point you do have to bring it back to a node to say, okay, if site A and site B saw this, they only see part of the picture, but together, you know, it's a single picture. So there are some real big analytic challenges that, you know, both Kaspersky and Dragos face.
Yeah, and to circle back on that, right? A lot of, you know, there's been several talks on machine learning and AI, and based on my background, I would have looked at that some of those things to help challenge those is using something like a Markov model with a fingerprint. So all of us are familiar with, you know, our phones automatically selecting the best filter for music, right? So if I'm listening to electric dance music or I'm listening to country, it'll pick and choose. And if you're able to pick, let's say that's the Alan Bradley, and build a profile of it, and you know that that should be talking to that, you know, it's going to help a lot with that correlation effect because you're able to see behaviors that are far more than just, you know, just the attack. You'll see the behavior change, and then you'll see the attack too. So you could augment and also reduce some of the hunting hours, and maybe Kaspersky, you know, do you have features there that would really reduce man hours for your analyst, but also the consumer?
Yes, we just developed the special machine learning you know, solution combined together with the kicks, so we can put for the to the customer facility all together, like kicks for nodes and the machine learning thing, and it works pretty good. We already have a couple customers, and they're happy with that. And that type of the approach can save the man hours in terms of regarding the analysis and everything.
And Ron, you very creatively created a little note at the beginning, but and no one actually got to the end attack, right, or discovered the clue in the note.
Yeah.
Is that right, or did you guys figure Did you figure out anything from the note?
I guess no.
So maybe explain what you were doing there. Let him in on the secret.
So my colleague and I, Mark Gittin, we were up 6 a.m. and I kind of wanted to turn this into a bit of a fun, you know, joke, right? All of a sudden, all three competitors get this big, massive files, dump of files, and I'm laughing, and I'm like, you know, I would be a nasty person, and I was like, let's make this even more fun and turn this into a real-world challenge, right? If you get a threat from X, you know, organization or X hacktivist or whatever it is, I'm like, they're gonna write something similar to what I did. So I wrote them this note, and you know, I sent it out to the team first, and then I allowed Dale to share it first, because I wasn't sure if I was allowed to. And inside there, at the very end of it, it says, "You have the power." And no one picked up on that little note that it was actually a direct link to the powerhouse at the end, because I didn't mind if they saw that hint and went after that particular asset, because that was the end game. But they still had to link everything, which was the beautiful part of the challenge anyway. So even if you went, you know, you started from the beginning in the DMZ, which is where most people would have started their hunt, because you're usually going to see your alerts start from there. You could have also started from the end, because you would have had a catastrophic failure. So you would have started from one or the other end. And so it was really unique that no one saw that beautiful little feature that I did.
Can you go back and pull up the Dragos screen there? So how close did they get to the end? Because you guys were actually chaining some things together. How close did they get, Ron?
So Kaspersky got into the QSX, the Dell box there, the privileged one, and that's kind of, they were only 2 steps away from seeing the unit in the bottom, which is the powerhouse, which is where the telemechanic devices, which now is a Schneider Electric product. Dragos was several, so you can see they're several steps away, but they're actually really only 3 steps away. So you guys were not that far away, and neither was Kaspersky as well. You guys were way closer if you had maybe the time or just, you know, a few other heuristics or whatever your sampling was.
And there were actually, the final attack was what, shutting off the power in the powerhouse?
Yes, exactly. So very, very little was published about telemechanic devices, so I kind of struggled there, and I had to improvise a little bit. But I was lucky to have a Modbus simulator with a master and a slave. And what we did is we simulated a whole bunch of set points with voltage simulations. So I set a bunch of values with my colleague, and you know, at last minute we're like, okay, how do we do this? What would be really unique? And if I were an attacker, I would start doing data shifts. So I would slowly start probing if I had real data and start upping, you know, for example, I'm looking at the registers or I'm changing the coils. I would start doing small little shifts in the data. But once I'd done several packets very slowly, I said, you know, at this point as an attacker, I would know what it is. So, okay, I can execute my CVE correctly because I've correctly identified and I know I'm going to kill this device. So then what I did was, and then I just, with the Modbus tool, I can send roughly 1 packet every 25 milliseconds. So then basically I went after a DOS. But what I did was I sent a whole bunch of Fs with a whole bunch of pipeline traffic, and then I had my colleague kill the server, and there's a whole bunch of resets. So it would simulate, someone really, doing an end game kind of attack on a device, and that's what the final thing was that everyone missed.
Okay, well that's good. And maybe if we circle back around now to the whole purpose, the original purpose of the challenge, and I always hesitate to ask the vendor this question, is because probably the answer is just buy our product. But how is an asset owner? I mean, the whole purpose of this is there's 20-some solutions out there. Now, the field is narrowing, and it will narrow more, but you have all these solutions out there. Something like this takes a lot of time. Even if you put it on your own network, you're not going to see a lot of attacks, so you could test asset inventory. But how is the community, the asset owner, supposed to test these products and determine which one is the right solution for them? I mean, either one of you can jump in on that.
Okay. I think that, well, as I mentioned before, if we're going to the customer facility, to asset owners, the best approach is to work really close with the asset owner, understand what is happening, what is the type of the technological process, what are the critical parameters. And if we work really close together, we understand each other, we basically in the same direction. This way, we can be sure that most of the attacks, or maybe 100% of the attacks, will be detected, and the information will be sent to SOC analysts.
Actually, let me just push you on that a little bit. I understand how you could test asset inventory that way. You have your inventory, you connect up to my network, I can see how much you find. But there aren't these kind of serious attacks happening on the network, right? So the owner-operator is going to say, yes, I see you have this visibility, but they're not really going to be able to know whether your product, when it's really needed, is able to step up. So how would they actually test the ability of your product to detect attacks? And we'll come back. I'll maybe give you a chance to answer that first, Dan, and then if you wanted to add anything.
Yeah, and I think that's where this event was really important, and like a vendor neutral event like S4, right? Like coming in, we didn't know the PCAP, we didn't know you before. Like challenging vendors to say, if this is what you're going to say, like show it, right? And asking these hard questions. I think that's part of how the community will push forward. More vendors also participating will help, right? Because watching their demo, we learn things, as I'm sure they learn things from watching ours, and so it both challenges the message, but it also allows us to grow, and as we also iterate, as we go home and dig back through and be like, okay, how do we get it in? I feel like it's a win-win having this type of format.
And Ron, I really can't tell you how much work Ron put in himself, and Mark, his teammate at Deloitte, and some of the other people, Corey from Gravwell and some people from Schneider and Rockwell. They really put in a tremendous amount of hours to create the attack. Is there any kind of final thoughts you had on the challenge?
Oh boy, I have so many comments. So just to iterate on how much it worked, personally, I put in 400 to 500 hours of my own personal volunteer time. Not paid. And that is on top of my job that's roughly 70, 80 hours a week. So figure out the math there. I didn't sleep, and
And you're single.
No, I have a relationship, but I think I'm going to be single soon.
Oh, okay.
And my partner, I got to give her a lot of credit for allowing me to do these things, because she doesn't understand what any of us do. I don't know if all of your guys' partners understand, and if yours does, well, you're lucky. Mine is, she's a great person, but doesn't understand what we do, and this is really hard, for people to understand. But I want to circle back to, how do you choose? Because you guys were talking about POCs, and POCs are a commitment thing, right? It takes a lot of time. And I'm going to use an analogy of a car, right? We can all say, like, the Lexus is the best, or if I want a McLaren, they're all really great cars. But how do I know which car to buy? How do I know? Do I go for a test drive? Okay, well, you can give me a technical demo, but I'm not going to give you access to my facility. Maybe a test bed, maybe. But that's another commitment. Okay, well, how do I know before I buy the car or deploy the solution and put the bodies and the time and the commitment? Okay, well, then I lease the car for 6 months or 1 year. But that's a commitment issue. There's a challenge there for the industry from the vendor sales side of it, right? We all want to say our car is the best or my product's the best. But also there's way more legwork in there, and even the Dragos team and Kaspersky, this was a training exercise. They got access to verticals that maybe you don't normally talk to, and I think it was a really good information sharing thing. And I hope, last year was a pipeline, this year was a mine. I don't know what Dale's going to get me next year, so I get to learn. So I'm happy, and I really got to give everyone credit.
Okay. Well, please, one last round of applause for Ron and the team and our brave competitors. Thanks, guys.
Yeah.